Hello, my name is Elias Anderson and this is my math video project. I was assigned problem 3, and for the first part we're supposed to find the first partial derivatives, and that's when I looked at the first equation, the original problem, and I found fx, so 2 times 2 is 4, 2 minus 1 is x, or just 1, and then I did the same for this part right here, minus the x, and we're left with the y. Next, I found fy, which is, we only use the y parts of the equation, so 1 y times negative 4 is just 4, minus that y, and we're left with the x, and then for 3 times 1/3, it's 1 y, right here, and then 3 minus 1 is 2, and we're left with the 2. Then finally, we did the same thing for the last part, which is 1 times negative 5 is negative 5, minus 1y is 0. Next, I'm supposed to find all the critical points. So in order to do that, I put the partial derivatives equal to 0, so 0 equals 4x minus 4y, and I divided both sides by 4, and put them equal to each other, and then found that y equals x, and I used substitution, so y in terms of x, and then I used solver to find that y equals negative 1 and y equals 5. And since x is equal to y and y is equal to x, then x equals negative 1 and x equals 5. And that's how I got these critical points of negative 1, and 5, 5. Then I'm supposed to find the second partial derivatives. So for this, we use the for the first part, fxx, we use derivative of fx with respect to x. So that's 4. If we look at this equation, it's 4. And next, we do derivative of f of x with respect to y, so negative 4. So that's the negative 4 right here. 1 times negative 4 is y is 4. Minus 1 is the y, so we have a 0 instead of the y. And then we use the derivative for fyx, we find the derivative of fy with respect to x, so we use the second equation, and that's where we get negative 4, and then we do fyy, so derivative of fy with respect to y, we get 2y. 2 times y is 2y minus 1, we're left with this y. Finally, I was supposed to the critical points according to the determinant test, so I wrote down the determinant test equation, and then I plugged in those second partial derivatives into the equation in order to get that, and then I plugged in the critical points into that equation to find that I get negative 24 for negative 1, 1, or negative 1, negative 1. And since f of negative 1, negative 1 is less than 0, it's a saddle point. So I put that in the saddle point. And then finally, I plugged in the point 5, 5, and found that got me to 24, so it's in a relative extreme. So if we look at f of x, or fxx, it's 4, and because 4 is greater than 0, f has a relative min at 5, 5. So that's why I put the relative min at 5, 5, and we exclude the relative max since we have used all our critical points. Thank you very much.